Hello and welcome to Mr. Rahman's maths class. Today we're going to be looking at exam style questions where you have to apply Pythagoras Theorem combined with trigonometry. Let's start with this question here. So this is a 5-mark question. The diagram shows a cuboid A, B, C, D, E, F, G, H, a 3D shape, and it wants you to calculate the angle BHF. So from B in the corner to the top right at the back, coming forward to the left and going down to the corner H, and then going back to F, which is bottom right and the side furthest away from the screen. Okay, so try to pause the video and give yourself no more than 5 minutes showing all your working outs and attempt this question. And afterwards we'll go through it and you can see if you got it correctly. So pause it now and attempt the question. Okay, so hopefully you've had a go at that. And let's have a look at how we deal with this question. So here's the cuboid. The first thing we need to establish is that we're dealing with a right-angled triangle because Pythagoras Theorem and trigonometry, they are used with a right-angled triangle. Apart from the sine and cosine rule, you need to have a right angle triangle to use sine, cos, tangent and the Pythagoras theorem. So firstly, if you look at the back face of the cuboid, BFE, there is a right angle there. And because it's on the same plane, so what we've done is we've taken that line and staying on the same plane, we've brought that corner forward to H. So BFH is on the same plane as BFE. So this right angle here moves along as you move the corner E forward to H. So BFH is also a right angle. So that means you can use Pythagoras theorem and trigonometry. So we already have the size of the line HG, which is 11 centimeters, and the line GF, which is 6 centimeters. So using Pythagoras theorem, which is a squared plus b squared equals c squared, and c squared has to be the longest side, the hypotenuse. So in this case, we're looking for, because we have GF and HG, we can use that to find the length FH, using the right angle triangle that forms on the base here. So FGH is a right angle. So FH is the hypotenuse, the longest side, so that's C. So putting that into there, we have 11 squared plus 6 squared gives us HF squared. So that's 121 plus 36, that's 157 is the square of the line, or the length of the line HF. And using your calculator, that will come to 12.529, and there's some more numbers. I've just rounded it to that. You could also round it to 12.53. But in order to reduce the error later on, we try to use as many decimal places as possible while we're doing the calculation. So the next step is that we can use trigonometry to find the angle BHF. Okay, so we know that FH is 12.529, and we have 8 centimeters as BF. So we've got this side, we've got this side. We don't know the hypotenuse here, which is BH or HB. But we need to find the angle here. Now, using the mnemonic SOHCAHTOA, The sine is the opposite over the hypotenuse. The cosine is the adjacent over the hypotenuse. The tangent is the opposite of over the adjacent. Now, as we don't know what the hypotenuse, the length of the hypotenuse is in this situation, so I've just taken BFH and represented it here. We do know the opposite and the adjacent. So the angle here, opposite to the angle is the line BF, which is 8 centimeters, and adjacent to the angle is the line HF, which is 12.529, which we worked out earlier. So it's most appropriate to use the tangent. So tangent is the opposite divided by the adjacent. So we get the tangent of BHF is 8 centimeters divided by 12.529 centimeters, giving us a ratio of 0.6385. If you use your scientific calculator, that number of course carries on with lots more decimal places, and if you use the whole of the number that your calculator gives, you get the least amount of error. So when you do 8 divided by 12.529, whatever number that comes up, including, I think the next one is a 1 after the 5, just keep all of that and then use the inverse tangent function of your scientific calculator to find the size of angle BHF, which will be 32.56.